In the very first moments after the birth of the universe, atoms were impossible. Not unlikely. Impossible. The temperature was so high that even the most basic particles could not remain bound. Energy dominated everything. Space was filled with a dense, seething plasma where particles appeared and vanished faster than any structure could form. In this environment, the idea of matter as we know it had no meaning. Reality had no memory. Particles collided, annihilated, and reformed endlessly. Quarks could not settle into protons. Electrons could not remain near anything. Forces existed, but none of them could establish long-lasting order. The universe was not broken. It was simply too energetic to allow calm. And yet, expansion changed everything. As space expanded, energy diluted. Temperature dropped. Time began to stretch interactions apart. This cooling was not dramatic. It was patient. And patience is the precondition for structure. The first miracle was survival. Matter and antimatter should have annihilated each other completely. According to symmetry, they should have existed in equal amounts. If that had happened perfectly, the universe would have ended as pure radiation, light without substance, motion without memory. But it didn't. For reasons we still do not fully understand, matter slightly outnumbered antimatter. One extra particle for every billion pairs was enough. When annihilation ended, that tiny excess remained. Everything you see, every atom in your body, every star, every planet, is built from that imbalance. Atoms exist because the universe was not perfectly fair. From this fragile asymmetry, the next steps became possible. Quarks cooled enough to bind into protons and neutrons. Gluons, which normally resist confinement, allowed themselves to trap particles together. Nuclear forces, normally violent at close range, became stabilizing instead of destructive. This was not guaranteed. If the strong nuclear force were slightly weaker, protons would fall apart. If it were slightly stronger, everything would fuse too quickly. Stability exists only within a narrow corridor of physical possibility. As minutes passed, the first nuclei formed. Hydrogen appeared. Helium followed. These were not atoms yet, just bare cores, stripped of electrons, floating in a hot cosmic soup. Still, the foundation was laid. Structure had survived the fire. As you rest with this idea, imagine the universe learning restraint for the first time. Forces that once tore everything apart now allowed proximity. Interactions that once erased information began to preserve it. Atoms were not born in an instant. They were negotiated. In the next movement, we will explore the quietest and most important step of all, the moment when the universe became calm enough for electrons to settle and for true atoms to finally exist. Once the first nuclei existed, the universe still had one final obstacle to overcome. Protons and neutrons could survive. Hydrogen and helium nuclei could form. But true atoms, stable, enduring atoms, required something far less intuitive. Electrons had to learn how not to fall. Classically, an electron orbiting a positively charged nucleus should lose energy and spiral inward. It should collapse in an instant, releasing radiation until it merged with the proton. If the universe followed only classical rules, atoms would be impossible. Matter would be unstable. Structure would never persist. And yet, electrons do not fall. They hover. They occupy regions of probability. They refuse to be pinned down. This is not because electrons are careful. It is because reality is quantum. At the smallest scales, particles are not points following paths. They are waves of possibility. An electron in an atom is not a tiny planet circling a star. It is a standing wave, a pattern that can exist only at certain energies, in certain shapes, at certain distances. These allowed states are not chosen. They are enforced. Quantum mechanics forbids collapse by imposing limits. The uncertainty principle ensures that an electron cannot have both a perfectly defined position and zero motion. To fall into the nucleus would require certainty that nature does not permit. In this way, atoms exist because the universe refuses precision. Electrons settle into the lowest possible energy state, but no lower. They cannot radiate away all motion. They cannot sit still. The atom becomes a balance between attraction and uncertainty, between pull and prohibition. This balance is astonishingly delicate. Change the mass of the electron slightly, and atomic sizes shift. Alter the strength of electromagnetism, and chemistry dissolves. Modify quantum rules even a little, and atoms either collapse or never bind at all. The universe does not favor atoms by intention. It allows them by constraint. As expansion continued, the temperature dropped further. Eventually, the cosmic plasma cooled enough for electrons to attach permanently to nuclei. This moment is known as recombination, the first time true atoms could exist freely. Light, once trapped by constant scattering, was suddenly released. The universe became transparent. Radiation began its long journey across space, carrying with it a memory of that first atomic calm. Atoms did not shout their arrival. They quietly endured. As you rest with this idea, imagine electrons as restless guardians of structure, never stopping, never collapsing, never allowing matter to fall into itself. Their motion is not chaos. It is protection. In the next movement, we will explore how this fragile atomic stability made chemistry possible, and why complexity could not exist without these quantum boundaries. Once atoms became stable, the universe crossed a subtle threshold. Stability alone is not enough to create richness. A stone can be stable and remain simple forever. What made atoms extraordinary was not just that they endured, but that they could relate. Chemistry became possible. This did not happen because atoms were designed to connect. It happened because their internal structures allowed variation. Electrons occupy discrete energy levels. These levels define how atoms interact, how close they can approach, and how they respond to one another's presence. An atom carries its history on its surface. The arrangement of electrons determines everything about an element's behavior. Hydrogen, with its single electron, is open and eager to bond. Helium, with a complete outer shell, is quiet and indifferent. Carbon, balanced between stability and flexibility, becomes the architect of complexity. These personalities are not metaphors. They are consequences of quantum rules. Atoms recognize each other not through awareness, but through compatibility. When energy levels align, electrons can be shared, transferred, or rearranged. Bonds form. Molecules appear. Patterns emerge that are richer than their parts. This is where the universe begins to experiment. With chemistry, matter gains memory. Molecules can persist, break, and reform. Reactions follow pathways. Outcomes depend on context. The same atoms can assemble into countless forms: gases, liquids, solids, crystals, chains, and networks. None of this is guaranteed by atomic stability alone. If energy levels were continuous instead of discrete, electrons would slide endlessly. Bonds would not hold. Molecules would dissolve as quickly as they formed. Complexity would be impossible. The discreteness of quantum states gives matter punctuation. It allows pauses. It allows repetition. As stars formed and ignited, new elements were forged. Heavier atoms emerged in stellar cores and explosive deaths. Each new element added a new set of possibilities to chemistry's language. Oxygen allowed combustion and respiration. Nitrogen enabled cycles. Phosphorus carried energy. Iron anchored planets. Atoms became storytellers. As you let this settle, imagine the universe learning how to combine, not randomly, but rhythmically. Allowed states guiding interaction, forbidden states preventing collapse. Complexity rising not through chaos, but through constraint. In the next movement, we will explore why atoms remain rare, delicate islands of order in a universe that still overwhelmingly prefers emptiness, and how gravity learned to gather them without destroying them. Even after atoms formed and chemistry became possible, the universe remained an inhospitable place for structure. Most of space was, and still is, empty. Vast, cold, expanding emptiness dominates reality. Against this backdrop, atoms are not the rule. They are the exception. Expansion is relentless. As the universe grows, matter thins out. Distances increase, temperatures fall. On the largest scales, gravity struggles to compete with expansion, and emptiness wins. Left alone, atoms would drift apart forever, isolated, never gathering into anything more complex than rare encounters. And yet, they gather. This is where gravity enters the story, not as a conqueror, but as a collector. Gravity is the weakest of the fundamental forces, yet it acts over infinite distance. It does not overwhelm atoms. It whispers to them, patiently, across space. In regions where matter is slightly denser than average, gravity gains a foothold. Atoms drift closer. Density increases. Attraction strengthens. A slow feedback begins. Clouds form. Structures emerge not through force, but through accumulation. Importantly, gravity does not crush atoms immediately. Quantum pressure, electromagnetic repulsion, and thermal motion resist collapse. Only when mass becomes enormous does gravity dominate fully. Until then, atoms retain their identity, even as they gather into clouds, disks, and eventually stars. This balance is essential. If gravity were stronger, atoms would collapse too easily, forming black holes instead of stars. If it were weaker, matter would never gather at all. The universe would remain a thin mist of particles, chemically rich but forever dispersed. Stars mark the next compromise. Inside stellar cores, atoms are pushed to their limits. Temperatures soar, pressures rise, hydrogen fuses into helium. Atoms are transformed, but not erased. New elements are born. The periodic table grows, one stellar generation at a time. Outside stars, atoms rest. They cool. They bond. They settle onto planets. They form oceans, atmospheres, rocks, and eventually, living systems. All of this happens in small pockets, surrounded by overwhelming emptiness. As you sit with this image, imagine atoms as travelers in a vast void. They survive not by dominating space, but by finding places where balance holds. Gravity gathers without destroying. Expansion stretches without erasing. The universe does not favor matter. It tolerates it. In the next movement, we will look deeper still, at why the laws of physics allow such balance at all, and how slight changes would erase atoms entirely from reality. At some point, the question shifts from how atoms exist to why the laws of physics allow them at all. The more closely we examine these laws, the more unsettling the balance appears. The universe seems tuned, not broadly but precisely, to permit stable matter. This is known as fine-tuning. The strengths of the fundamental forces are not arbitrary. Electromagnetism, the strong nuclear force, the weak force, and gravity sit in narrow ranges. Shift any of them slightly, and atoms either never form or never survive. If electromagnetism were a little stronger, electrons would cling too tightly to nuclei, preventing chemical bonding. If it were weaker, atoms would fail to hold electrons at all. Chemistry would vanish in either case. If the strong nuclear force were slightly weaker, protons would not bind in nuclei. Hydrogen would decay. No elements beyond the simplest could exist. If it were slightly stronger, nuclear fusion would run too easily. Stars would burn violently and briefly, or never stabilize at all. Gravity, though weak, must be weak in exactly the right way. Stronger gravity would compress matter too efficiently, collapsing atoms into dense states before chemistry could emerge. Weaker gravity would prevent stars and planets from forming, leaving atoms scattered and lonely. Even particle masses matter. Change the electron's mass, and atomic sizes shift beyond usefulness. Alter the mass difference between protons and neutrons, and hydrogen becomes unstable. Modify the cosmological constant, and the universe either collapses too quickly or expands too fast for matter to gather. Atoms exist in a narrow corridor of possibility. This does not mean the universe was designed for atoms. It means that atoms exist only in universes that permit them. Many physicists interpret this through selection effects. We observe this balance because only in such a universe can observers arise. Still, the precision is striking. It suggests that structure is not a default outcome. Chaos is easier. Featureless energy is simpler. A universe without atoms is far more likely than one with them, unless something constrains the rules. Whether this constraint comes from deeper laws, multiple universes, or principles we do not yet understand remains unknown. What matters is the consequence. Atoms are not guaranteed. They are contingent. As you let this idea settle, imagine countless possible universes flickering into existence. Most too hot, too empty, too violent, or too uniform to allow matter to settle. In a few rare ones, balance holds just long enough for atoms to persist. We find ourselves in one of those rare, quiet places. In the next movement, we will explore what atoms ultimately make possible. Not just chemistry or planets, but memory, time, and the ability of the universe to know itself. Before atoms existed, the universe had no way to remember itself. Energy flowed, interactions happened, but nothing endured long enough to leave a trace. Without stable matter, there is no record, only motion without history. Atoms change that. An atom is a pause in the flow of energy. It holds position. It resists change. It allows information to persist. When atoms bind into molecules, and molecules into structures, the universe gains the ability to store states, to preserve arrangements, to create before and after. This is what memory looks like at the physical level. A crystal remembers its lattice. A molecule remembers its bonds. A rock remembers pressure and heat. These are not metaphors. They are literal records of past interactions, encoded in atomic arrangements. Without atoms, time would pass without accumulation. With atoms, time leaves marks. This is why history becomes possible only after atoms appear. Stars form, burn, and die, leaving elements behind. Planets gather layers, each one a chapter. Chemistry explores pathways, repeating some, abandoning others. Eventually, biological systems emerge, using atoms to encode instructions, to replicate patterns, to remember successes and failures. Life is atomic memory in motion. Even thought depends on this stability. Neurons fire, but their structure persists. Synapses change slowly, storing experience. Consciousness itself rests on atoms that endure long enough to carry information forward. Atoms do not think, but without them, nothing could. As you rest with this idea, imagine the universe before atoms as a river with no banks. movement everywhere, but no place to pause. Then imagine the first atoms forming like stones in the current. Small, scattered, but enough to shape flow, to create eddies, to allow patterns to repeat. This is how meaning enters physics, not through intention, but through endurance. In the next movement, we will explore an even deeper layer. Why atoms allow not just memory, but identity. Why things can be distinct, separate, and yet connected in a universe that once had no boundaries at all. Atoms do something that feels ordinary only because we are used to it. They create boundaries. They allow one thing to be separate from another. They make it possible for this to exist without immediately dissolving into everything else. In a universe that began as a nearly uniform sea of energy, this is a profound shift. Before atoms, distinction had little meaning. Particles interacted constantly, exchanging energy, appearing and disappearing. Space was filled with motion, but not with objects. There were no surfaces, no edges, no interiors. Everything blended into everything else. Reality had activity, but not identity. Events happened, but nothing endured long enough to be named. Atoms changed that by introducing persistence. An atom occupies space. It resists intrusion. Its electrons define a region that other atoms must respect. When atoms come close, they do not merge automatically. They negotiate distance. They arrange themselves into patterns that repeat. This is the origin of form. Form is not imposed from above. It emerges from atomic limits. Electromagnetic repulsion prevents atoms from collapsing into one another. Quantum rules prevent electrons from sharing the same state. These constraints carve space into territories. Each atom becomes a small domain where certain arrangements are allowed and others are forbidden. This is how separation arises. Once atoms exist, objects become possible. A molecule is no longer just energy flowing, but a specific configuration that can be identified, moved, and changed without losing itself. A crystal can be distinguished from its surroundings. A grain of dust can travel through space and remain a grain of dust. Identity begins as atomic stubbornness. This separation does not mean isolation. Atoms interact constantly. They exchange electrons, form bonds, vibrate, and respond to fields. But interaction now happens between entities that maintain coherence over time. Relationship replaces fusion. Contact replaces collapse. This distinction is subtle but essential. Without atoms, there can be interaction, but not relation. Everything affects everything else immediately and irreversibly. With atoms, effects propagate through structures. Causes lead to consequences that can be traced. Systems emerge that are neither fully independent nor fully merged. Planets are possible because atoms remain atoms under pressure. Oceans exist because molecules remain molecules while flowing. Atmospheres persist because gases remain discrete particles rather than blending into radiation. Even living cells depend on this balance. Their membranes are atomic boundaries. Their internal chemistry depends on separation between inside and outside. Life is not a rejection of physics. It is an intricate use of atomic identity. This idea becomes even deeper when we consider scale. An atom is mostly empty space, yet it behaves as a solid unit. This paradox is essential. The emptiness allows flexibility, vibration, and interaction. The structure enforces limits. Identity arises not from density, but from pattern. Patterns can persist even when their components move. This is why a river remains a river even as its water changes. It is why a body remains a body even as atoms are exchanged. Atomic structure allows continuity without rigidity. It permits change without erasure. This is the physical origin of individuality. Every object in the universe is a temporary agreement among atoms to maintain a certain arrangement for a certain time. Mountains are slow agreements. Clouds are fast ones. Living organisms are extraordinarily delicate agreements, maintained through constant exchange. Atoms make this possible by being stable enough to persist and flexible enough to rearrange. There is also an emotional consequence to atomic separation. Because atoms create boundaries, they also create vulnerability. Anything that has a boundary can be damaged, altered, or destroyed. A universe with atoms allows beauty, but it also allows loss. Stability always carries the possibility of breaking. This fragility is not a flaw. It is the price of form. If atoms were absolutely rigid, nothing could change. If they were too fluid, nothing could last. The universe sits between these extremes. It allows things to exist long enough to matter, but not forever. This gives time direction and experience weight. Thought itself depends on this compromise. Neurons are distinct cells. Synapses are precise gaps. Signals travel along defined paths. Memory exists because structures persist long enough to be modified. Consciousness relies on a world where boundaries are real, even if they are permeable. Atoms allow the universe to be plural. They create many instead of one. They allow difference without destruction. They permit complexity without chaos. Without atoms, there would be no here and there, no before and after, no self and other. There would be motion, but no meaning. Atoms also allow comparison. Because things are separate, they can be similar or different. Patterns can repeat. Laws can be discovered. Science becomes possible only because the universe contains stable, distinguishable units that behave consistently. Atoms make regularity visible. In this sense, atoms are not just physical entities. They are the grammar of reality. They allow the universe to speak in sentences rather than noise. They turn continuous flow into discrete structure. They make questions possible, answers stable, and understanding cumulative. They also allow silence between events, pauses between interactions, space for reflection inside physics itself. As you rest with this idea, imagine a universe without atomic boundaries. No surfaces to touch, no objects to recognize, no separation between observer and observed. Experience would be impossible, not because nothing happens, but because nothing stands apart long enough to be known. Atoms make knowing possible by making distinction possible. They do not divide the universe into disconnected pieces. They create a fabric of relative independence, where parts can change without erasing the whole. This is the quiet foundation of diversity, physical, chemical, biological, and experiential. The universe does not fragment because of atoms. It articulates itself through them. And because of this articulation, existence gains shape, rhythm, and quiet continuity across immense spans of time. In the next movement, we will begin to turn toward the largest scale again, asking why a universe that allows atoms also allows them to persist for billions of years, and why this persistence may not be permanent at all. Atoms are not only remarkable because they can exist, they are remarkable because they can endure. In a universe defined by change, motion, and expansion, longevity is rare. And yet atoms persist for billions of years, carrying structure across cosmic time. This persistence is not guaranteed by simplicity. It is earned through stability. At the heart of every atom is a proton, and the proton is one of the most stable objects known in physics. As far as we can tell, it may never decay. Some theories predict an eventual breakdown after unimaginable spans of time. But even those timescales exceed the current age of the universe by many orders of magnitude. This means that matter, once formed, is allowed to remain. Neutrons inside atomic nuclei are also stabilized. Alone, a neutron decays quickly, but when bound with protons, it becomes long-lived. The nucleus transforms fragility into endurance through cooperation. Stability is not an individual property. It emerges from relationships between particles. Electrons, too, are stable. They do not wear out. They do not lose charge. They do not age. An electron created in the early universe is indistinguishable from one created moments ago. Atoms, therefore, carry pieces of the past into the present unchanged. This gives the universe continuity. While stars ignite and burn out, while galaxies collide and drift apart, atoms quietly persist. They are recycled, rearranged, and redistributed, but rarely destroyed. Even inside stars, atoms are transformed rather than erased. Hydrogen becomes helium. Helium becomes heavier elements. Matter changes form, but not existence. Decay exists, but it is selective. Some atoms are unstable, but most of the atoms that shape planets, oceans, and life are astonishingly durable. Carbon, oxygen, nitrogen, iron. These elements can persist for billions of years without alteration. This allows chemistry to unfold slowly, patiently, without being constantly reset. Time becomes usable. If atoms decayed quickly, complexity would never accumulate. Structures would dissolve before they could interact. Patterns would fail to repeat. Life would be impossible, not because conditions were hostile, but because nothing could last long enough to matter. The universe avoids this fate by allowing long atomic lifetimes. This stability is closely tied to energy scales. The forces that bind atoms operate far above the energies of ordinary environments. Thermal motion on planets is too weak to break nuclei. Chemical reactions rearrange electrons, not cores. Destruction requires extremes: stellar interiors, supernova, or deliberate intervention. Most of the universe is gentle enough to preserve atoms. Even cosmic radiation, though energetic, rarely disrupts atomic structure in a lasting way. Space is harsh, but not annihilating. It strips, excites, and ionizes, but it usually leaves nuclei intact. Atoms travel through interstellar space for millions of years without losing identity. This endurance creates a slow universe. Change happens, but it is layered. Atoms provide a baseline that evolution, geology, and cosmology can build upon. Without this baseline, the universe would flicker instead of flow. There is also a deeper implication. Because atoms persist, cause and effect can stretch across time. A reaction today can depend on an arrangement billions of years old. Elements forged in ancient stars become the building blocks of new planets. Atoms carry history forward without awareness. You are made of such history. The carbon in your body may have formed in a star that died long before the sun existed. The iron in your blood was forged under pressures that no longer exist. Atoms bridge epochs effortlessly. They ignore the boundaries we impose on time. As you sit with this thought, imagine the universe as a slow-moving river. Stars are waves. Galaxies are currents. Atoms are the water itself, always moving but never disappearing. This persistence also introduces impermanence in a different way. Atoms last, but structures do not. Mountains erode, cells die, civilizations vanish. The same atoms are reused again and again, indifferent to the forms they inhabit. Stability at the smallest scale allows impermanence at larger ones. This balance is essential. If atoms were permanent and structures eternal, nothing would change. If atoms were fragile and short-lived, nothing could persist. The universe allows atoms to last so that higher-level forms can come and go. Meaning arises in this tension. Atoms do not care how they are arranged. But because they endure, arrangements can matter. The same set of atoms can be a rock, a tree, a thought, or a memory. Endurance gives possibility space to unfold. There is also comfort in atomic persistence. In a reality where stars die and galaxies drift beyond reach, atoms provide a quiet reassurance. Something remains. Something continues. The universe does not erase itself at every moment. It carries forward what it has already made. This is why the night sky is calm rather than chaotic. Atoms give the cosmos inertia. They slow change. They allow transitions rather than resets. Even the most violent events recycle matter instead of eliminating it. As you rest with this idea, imagine atoms as the universe's way of holding on to itself. Not through rigidity, but through patience. They are the reason the past is never completely lost. They also remind us that permanence and change are not opposites. They coexist at different scales. Atoms endure so that stories can unfold, end, and begin again. Because of atoms, the universe can afford to take its time. And time, once available, allows meaning to slowly emerge. In the next movement, we will approach a quiet reversal of perspective, asking not only why atoms persist, but whether they always will, and what a universe without atoms might look like once again, far in the future. This endurance shapes our sense of scale. Because atoms last, we can compare distant eras, reconstruct ancient events, and trust that the same laws apply across time. Scientific knowledge itself depends on atomic persistence. Experiments repeat. Measurements remain valid. Reality behaves consistently enough to be understood. Without long-lived atoms, understanding would dissolve as quickly as it formed. Atoms make continuity possible not only for matter, but for meaning itself. Atoms feel permanent because they outlast almost everything we encounter. Civilizations rise and fall. Species appear and vanish. Even mountains erode into dust. Against this backdrop, atoms seem eternal. But on the largest scales of time, even atoms may be temporary guests. Physics allows for this possibility. Some theories predict that protons are not truly stable. Their decay, if it happens at all, would be extraordinarily slow. Far slower than any process we observe today. Estimates place proton lifetimes at numbers so large they lose intuitive meaning. Trillions upon trillions of years would pass before a single atom noticeably changes. Yet the possibility alone changes the story. If protons eventually decay, atoms dissolve from the inside out. Chemistry ends. Molecules lose their cores. Matter thins into radiation and elementary particles drifting through an ever-expanding space. The universe does not collapse. It fades. Long before proton decay becomes relevant, other changes unfold. Stars burn out. Galaxies exhaust their fuel. Black holes dominate the remaining structure, slowly evaporating through quantum processes. Light stretches, cools, and redshifts into near-nothingness. This is the long future, quiet, sparse, and cold. In such a universe, atoms become increasingly rare. They are no longer recycled by stars or gathered into planets. They drift apart, isolated by expansion. Interactions become infrequent. Chemistry slows to a near standstill. Complexity unwinds, not violently, but gently. Eventually, if decay occurs, even these last atoms disappear. What remains is a thin soup of particles, radiation, and emptiness. A return, in some sense, to the simplicity before atoms first formed, but stretched across an incomprehensibly vast time. This future is not hostile. It is indifferent. Atoms were never promised eternity. They were allowed a window, long enough for stars, planets, life, and thought to arise. The universe grants structure temporarily, then withdraws it without drama. There is something profoundly calming in this. Nothing is taken away abruptly. Nothing is punished. Everything simply follows the rules it was given. From this perspective, atoms are not the goal of the universe. They are a phase, a stable pause between chaos and emptiness. A chapter where complexity is permitted to bloom before fading. As you rest with this idea, imagine the far future as a deep, quiet night with no dawn scheduled, no events rushing forward, no urgency, just slow transformation. Atoms dissolve, energy spreads, differences smooth out. Yet the existence of this ending does not diminish what came before. The fact that atoms will not last forever does not make their current existence fragile or meaningless. On the contrary, their impermanence gives weight to the time they do exist. They are precious because they are temporary. Every atom that exists now is participating in a rare era of structure. You are living during the age of atoms. There were eras before where atoms could not exist. There will be eras after where atoms no longer persist. Between them lies a long, quiet window where matter can hold shape, remember itself, and support awareness. This window is not short, but it is not infinite. As you breathe with this thought, consider how atoms carry both endurance and release. They persist long enough to matter, then let go without resistance. They do not cling to existence. They simply follow the path allowed by physics. In this way, atoms mirror life itself. They assemble, they interact, they change, they dissolve. And through this cycle, the universe experiences itself briefly as structure. In the next movement, we will turn inward again, toward what it means for a conscious mind to arise during this atomic era, and why the question of atoms is inseparable from the question of awareness. There is also another possibility, discussed quietly in cosmology. Atoms may survive forever, but become irrelevant. As expansion accelerates, distances grow so vast that even stable atoms can no longer interact meaningfully. Isolation becomes absolute. Each remaining structure exists in its own unreachable bubble of space. Physics still operates locally, but connection disappears. In such a future, atoms persist, but stories end. No new chemistry, no new combinations, no observers to notice endurance. Existence continues, but experience does not. This highlights something subtle about atoms. Their importance is not only in their stability, but in their ability to interact. Persistence without interaction is indistinguishable from absence on experiential scales. Atoms matter because they meet, they collide, they bind, they exchange energy, they form patterns together. A universe with atoms that never touch is functionally empty. This reminds us that structure alone is not enough. Relationship is required, and relationship depends on both endurance and proximity, a balance that the current universe happens to provide. This balance will not last forever. Expansion slowly stretches relationships apart. Even before atoms decay, their capacity to form new structures diminishes. The cosmic stage grows too large for actors to find one another. Yet again, this is not tragedy. It is completion. The universe does not rush toward its end. It drifts. Atoms simply participate until conditions no longer support interaction. They do not resist. They do not fail. They conclude. When viewed this way, the future without atoms is not a negation of meaning, but the quiet closure of a phase. Just as atoms once emerged from chaos, they may one day dissolve into simplicity again. Between these two silences lies everything that has ever happened. This vast timescale reframes our sense of urgency. Atoms give the universe patience. They slow everything down enough for reflection to occur. Without them, reality would be either too fast or too empty for awareness to take hold. Their eventual disappearance does not erase the fact that, for a long time, they made understanding possible. That alone is enough. Because atoms exist only for a while, every moment they support is unrepeatable. This does not create pressure. It creates presence. There is no need to rush a universe that has already provided billions of years for matter to think. Atoms do not ask why they exist. They simply exist while they can, and while they do, the universe is able to ask questions through us. Consciousness does not float freely in the universe. It does not arise in pure energy or empty space. Every known form of awareness depends on structure, and structure depends on atoms. This makes consciousness an atomic phenomenon, not in origin, but in possibility. Without atoms, there is nowhere for mind to appear. A conscious system requires boundaries. It needs components that can interact without dissolving. It needs memory, feedback, and persistence. Atoms provide all of this quietly, without intention. They create platforms on which complexity can rest long enough to reflect. The brain, like every organ, is an atomic arrangement. Neurons are not abstract processors. They are physical structures built from molecules, membranes, and ions. Signals move through chemical gradients and electrical potentials, all governed by atomic interactions. Thought is not separate from matter. It is a pattern occurring within it. This does not reduce consciousness. It grounds it. Atoms allow information to be stored and transformed. A neural connection strengthens or weakens through changes in molecular structure. Experience leaves traces. Learning is not metaphorical. It is atomic rearrangement. This makes awareness slow, fragile, and precious. If atoms were unstable, memory would evaporate. If chemical bonds broke too easily, thought could not persist long enough to form continuity. Consciousness requires a medium that is neither rigid nor fleeting. Atoms provide exactly that balance. The universe did not plan for minds, but it allowed the conditions for them. This distinction matters. Consciousness is not the purpose of atoms. It is a consequence of what atoms make possible when arranged in certain ways under certain conditions. Most atomic arrangements do not think, but some can. This makes awareness rare, but not miraculous. Life arises where chemistry becomes self-sustaining and information begins to regulate matter. This regulation depends on stable molecules, reliable reactions, and predictable interactions. All atomic gifts. Over time, systems emerge that do more than react. They model, they anticipate, they remember. At a certain threshold, experience appears, not as an object, but as a process. Atoms do not experience, but they host experience. As you rest with this idea, imagine consciousness as a flame that requires a very specific environment. Too chaotic, and it flickers out. Too static, and it cannot ignite. Atoms create the oxygen and structure that allow the flame to burn steadily. This flame does not illuminate the whole universe. It illuminates itself. Through conscious systems, the universe gains localized perspectives, not understanding in a cosmic sense, but awareness in a limited one. Each mind is a small window where matter notices its own patterns. This is not mystical. It is structural. Atoms enable complexity. Complexity enables life, and life enables awareness. Remove any layer, and the chain breaks. Consciousness is therefore inseparable from the atomic era of the universe. This also means consciousness is temporary. When atoms can no longer form stable structures, awareness will fade. Not dramatically, but inevitably. Minds are not eternal. They exist only while matter allows organization. This does not diminish their value. It defines it. Awareness matters because it is contingent. It arises during a narrow window when atoms are stable, chemistry is rich, and energy flows gently enough to sustain complexity. Consciousness is the universe briefly paying attention during this window. You are part of that attention. Your thoughts are atomic events arranged into meaning. Your memories are patterns held by molecules. Your sense of self is a continuity maintained by persistent structure. As you sit with this, imagine the vast stretches of time when the universe had no witnesses, before atoms and after them. Between those silences lies a long era where matter can look at itself and ask questions. This is that era. Consciousness does not conquer the universe. It listens to it. Atoms make listening possible by giving form to time, memory, and distinction. They allow the question, why, to exist, even if the answer remains open. In the next movement, we will explore why awareness was not guaranteed, why atoms could have existed without ever giving rise to minds, and what conditions tip the balance toward life and thought. It is important to notice that consciousness is not evenly distributed across matter. Most atoms will never participate in thought. They will drift through space, rest in rocks, or circulate through stars without ever becoming part of a nervous system. Awareness is therefore not a common outcome of atomic existence. It is a special arrangement within an already rare era. This makes conscious experience statistically insignificant, yet experientially absolute. From the inside, awareness is everything. From the outside, it is almost nothing. This paradox is only possible because atoms allow both perspectives to coexist. They are numerous enough to fill the universe, yet stable enough to host extremely localized phenomena. The brain is one such phenomenon. It concentrates matter into a form that can reflect, imagine, and feel. This concentration is fragile. Small changes in chemistry alter perception. Small disruptions in structure erase memory. Consciousness depends on precision sustained over time. Atoms provide that precision. They behave consistently. They follow rules that do not drift. An electron today behaves like an electron billions of years ago. This reliability allows biological systems to build upon previous states rather than starting over each moment. Without this consistency, learning would be impossible. Consciousness is therefore not only atomic, but conservative. It relies on the past remaining accessible. Memory is a form of temporal continuity, and atoms are its carriers. This also explains why awareness is embodied. There is no known mind without matter, no experience without a physical substrate. Even the most abstract thoughts depend on atoms arranged into functioning systems. This does not confine consciousness, it situates it. To be aware is to be located. Atoms give awareness a place in the universe. They anchor experience to regions of space and time. Each conscious system is a small island of perspective surrounded by vast, unconscious matter. This does not isolate minds. It contextualizes them. Awareness does not need to be everywhere to matter. It only needs to be somewhere long enough to notice itself. Atoms allow that noticing to persist. They create continuity between moments. They allow identity to stretch across time. Without them, there would be sensations without memory, reactions without recognition, change without understanding. As you reflect on this, imagine awareness as a slow wave moving through atomic structure, not separate from matter, not reducible to it, but dependent on its stability and richness. Atoms do not explain consciousness, but without them, consciousness would not appear at all. Atoms alone do not guarantee life. They guarantee only the possibility of structure. Vast regions of the universe contain atoms arranged in ways that will never think, never feel, never organize into anything more than silence. Rocks drift. Gas clouds glow briefly and disperse. Most matter remains forever lifeless. This makes life an outcome, not a rule. The laws of physics allow atoms to exist, but they do not demand that atoms become alive. Life appears only when several unlikely conditions overlap. Chemistry must be rich enough to support complex molecules. Energy must flow steadily, not explosively. Environments must remain stable long enough for patterns to persist and refine. These requirements are narrow. A planet must orbit at just the right distance from its star. Not too close, where molecules are torn apart. Not too far, where reactions freeze. The star itself must be stable, burning gently for billions of years. Sudden flares or rapid exhaustion would erase progress. Atoms provide the alphabet. Life requires grammar. Molecules must begin to organize information. Some structures must help create copies of themselves. Others must regulate reactions, separating inside from outside, maintaining balance against entropy. None of this is inevitable. Chemistry explores many paths that lead nowhere. Most fail. Life is not the natural end of chemistry. It is a rare feedback loop that chemistry occasionally stumbles into. When it does, atoms become participants in a process that preserves form through change. Even then, life remains fragile. A slight shift in temperature, radiation, or composition can erase it. Entire biospheres can vanish without leaving a trace. The universe does not protect life. It tolerates it briefly when conditions align. This tolerance is enough. Once life appears, atoms begin to behave differently. Not in their laws, but in their arrangements. They cycle through organized pathways. They are reused with purpose. Structures emerge that resist equilibrium by exporting disorder elsewhere. Life is matter temporarily avoiding rest. This avoidance depends entirely on atomic reliability. Chemical bonds must form and break predictably. Energy must be transferred without destroying structure. Information must be copied with high fidelity, but occasional variation. Atoms make all of this possible, but only barely. Evolution begins here. Over immense spans of time, simple life explores configurations. Most fail. A few persist. Complexity grows not by design, but by accumulation of workable arrangements. Atoms become part of cells, cells of organisms, organisms of ecosystems. None of this was required. The universe would be complete without life. Galaxies would still form. Stars would still shine. Atoms would still persist. Life is an addition, not a necessity. This makes it remarkable, but not central. As awareness emerges within living systems, another threshold is crossed. Atoms now participate in experience. They become part of nervous systems that sense, decide, and remember. Again, nothing in physics demands this outcome. It happens only where history, environment, and chance intersect. This reframes the meaning of life. Life is not the goal of atoms. It is a side effect of their stability. Atoms do not strive to become alive. They simply allow processes that, under rare conditions, give rise to self-maintaining complexity. Life is what happens when matter lingers long enough to experiment. As you rest with this idea, imagine countless atomic worlds where nothing ever stirs. Planets of stone. Oceans of chemistry that never organize. Stars illuminating emptiness. These worlds are not failures. They are the norm. Against this background, life is a quiet anomaly. It does not announce itself. It does not spread inevitably. It appears, adapts, and often disappears. This does not make life meaningless. It makes it specific. Life matters not because it is universal, but because it is local. It exists here now, in this narrow atomic window. It is something the universe is capable of, not something it insists upon. In the next movement, we will go one step further, asking how atoms, life, and awareness together allow the universe to reflect on itself, and why this reflection may be the rarest phenomenon of all. There is also a temporal requirement that often goes unnoticed. Life needs time. Not just duration, but continuity. Chemical experiments must be able to build on previous results. Successful arrangements must persist long enough to be reused and modified. This demands an environment that does not reset too often. Atoms make such continuity possible. They endure across cycles of heating and cooling. They survive impacts, radiation, and chemical change. Even when structures are destroyed, atoms remain available to form new ones. This allows life to restart, refine, and diversify over long spans. Planets act as laboratories. On their surfaces, atoms experience gradients of temperature, pressure, chemistry, and energy. These gradients drive reactions without overwhelming them. Oceans, atmospheres, and crusts create compartments where chemistry can specialize. Again, none of this is guaranteed. Most planets are sterile. Most environments are too extreme. Most atomic arrangements never cross the threshold into biology. Even on a life-friendly planet, emergence may be rare. Billions of years can pass before chemistry organizes itself into something that can copy, repair, and regulate. Life is slow to begin and easy to end. This slowness is important. It suggests that life is not an explosive inevitability, but a cautious process. It emerges only when atoms are given enough time to explore possibilities without interruption. Violence suppresses life. Stability nurtures it. Once life exists, it alters its environment. It reshapes atmospheres. It cycles elements. It creates new chemical niches. Atoms begin to circulate through living systems, spending time as parts of cells, tissues, and organisms before returning to non-living reservoirs. The distinction between living and non-living matter becomes fluid. Life does not create new atoms. It reuses them differently. This reuse introduces purpose-like behavior without intention. Atoms flow along pathways that preserve structure. Feedback loops stabilize conditions. Selection favors arrangements that last. Meaning emerges from persistence. This does not imply direction or destiny. It implies compatibility. Certain atomic arrangements happen to work under certain conditions. Those that work continue. Those that do not vanish. Life is therefore contingent twice over. It depends on atomic stability, and it depends on historical accident. Remove either, and life never appears. As you reflect on this, imagine a universe replayed countless times with slightly different initial conditions. In most versions, atoms exist, but life never does. In a few, chemistry crosses the threshold. In even fewer, awareness arises. We inhabit one of the rare runs where all these layers align. This does not place us at the center of reality. It places us at a crossroads of possibility. Atoms did not aim here, but they allowed here to happen. The universe is not simply an arena for physical events. It is also a process of self-discovery, a cosmic feedback loop in which energy, matter, and structure slowly become aware of their own existence. The moment atoms formed, the universe crossed a threshold. Not just physical change, but the possibility of experience. Atoms, by their nature, can hold structure. They can endure. They can preserve patterns across time, but patterns are meaningless unless they are recognized, and recognition requires awareness. In this sense, atoms are not just the building blocks of matter. They are the first words in the universe's attempt to understand itself. As complex systems form, these patterns become more sophisticated. Life and mind emerge as the latest in a long line of attempts to organize information meaningfully. Yet, all of this depends on the atomic substrate. Without it, there would be no complexity, no memory, no self-reflection. Atoms do not possess awareness themselves. They do not think, but they are the language through which thought emerges. They arrange themselves in ways that enable higher forms of organization, complexity, and experience. This is why atoms are not just a passive backdrop to life. They are an active participant in the process of creation. Through them, reality becomes something that can be known, remembered, and reflected upon. Atoms do not just enable life. They enable consciousness. The universe is capable of awareness because atoms can hold information. They can arrange themselves into systems that reproduce, that evolve, that remember. In this way, the process of life and mind is not an accident. It is a natural outcome of the properties inherent in atoms themselves. But awareness is not automatic. It is a rare outcome. Most of the time, atoms simply exist, interacting according to the laws of physics, following the forces that guide them. But on rare occasions, atoms organize themselves into systems that can process information, systems that can reflect on their own existence. These systems, like the human brain, are the product of billions of years of atomic organization. They are the culmination of a long, slow process that began with the formation of the first atoms. Consciousness is a product of atomic relationships, a consequence of atoms interacting in specific ways. It is not the goal of atoms, but it is an outcome of their ability to form complex, stable structures. The fact that consciousness exists is not proof that it is inevitable. It is simply the result of the particular properties of atoms combined with the right conditions at the right time. Atoms do not guarantee consciousness, but they allow it to happen. As you rest with this idea, imagine the universe as a giant puzzle, with each atom a piece that fits into a larger whole. Some pieces form simple shapes, while others combine to create more intricate patterns. Atoms provide the framework for complexity, but it is the arrangement of those atoms that gives rise to meaning. This is the language of the universe. Atoms are the alphabet. Life is the sentence. Consciousness is the paragraph. Together, they form a story, one that is still unfolding. In the next movement, we will explore how this story, written by atoms, might eventually reach its end, and what that means for the future of the universe and the life it has enabled. For atoms to be the language of the universe, they must be capable of something that transcends their simple existence. They must be able to communicate, not in the sense of speech or symbols, but in the sense of interaction. The fundamental property of atoms is their ability to form patterns and structures. These patterns, when organized correctly, can produce behavior that mirrors thought. This is the crucial aspect of atomic reality. Patterns that sustain complexity. When atoms combine into molecules, and molecules into cells, and cells into organisms, they do more than just exist. They begin to form relationships. They begin to process information, store it, pass it on. The moment life begins, atoms start to speak to each other in a new way. They start to form networks, systems that not only interact, but remember, adapt, and grow. In the simplest terms, the universe has learned to think because of the ways atoms organize themselves. This is the foundation of consciousness, the ability of matter to organize itself in ways that reflect, replicate, and evolve. This is what makes the human brain so extraordinary. It is not just a mass of atoms. It is a network of atoms that has learned to interpret its own existence. It is a network that has learned to reflect on itself, to think, to question, and to know. The brain is an example of how complex atomic systems can become more than the sum of their parts. It is a system that processes information not just to survive, but to understand. It is a network that not only reacts to its environment, but shapes its environment through thought. But the brain is not unique. Every living organism is an example of how atoms can organize themselves into systems capable of processing information. Life is a vast network of interactions, all based on the fundamental properties of atoms. The key to understanding consciousness is understanding that it is not a mystical force. It is not something that arises from nowhere. It is a product of atomic interactions, of the way atoms form complex systems that can process, store, and communicate information. Consciousness is not the result of one atom thinking. It is the result of billions of atoms working together in harmony, creating patterns of behavior that are more complex and more capable than the individual atoms themselves. And while atoms do not think in the way humans do, they are the building blocks of everything that is capable of thought. They are the foundation of awareness, of consciousness, of existence itself. Without atoms, there would be no life, no consciousness, no understanding. This is the power of atoms. This is the language of the universe. Before atoms existed, the universe was silent in a very specific way. It was not quiet because nothing happened. It was quiet because nothing could last. Energy moved, particles collided, forces acted, but no structure endured long enough to leave a trace. Reality flowed without memory. Then atoms appeared. With them came pauses, boundaries, persistence. The universe gained the ability to hold itself together, even if only temporarily. From that moment on, time could leave marks. History could begin. And one day, long after the first atoms formed, the universe began to listen to itself. Not everywhere, not always, but here and there, in small pockets of organized matter, awareness flickered into being. For a brief era, atoms arranged themselves into forms capable of reflection. Matter learned how to ask questions. This era is not infinite. Just as there was a time before atoms, there will be a time after them. Expansion will thin matter. Stars will fade. Structures will unwind. Whether through decay, isolation, or exhaustion, atoms will eventually lose their ability to support complexity. The universe will grow quiet again, not violently, not suddenly, but slowly, gently, without intention. This future silence will be different from the first. It will not be the silence of chaos, but the silence of completion. Everything that could happen within the atomic era will have had time to unfold. Every possible structure will have been tried. Every story that atoms could tell will have been told. In between these two silences lies everything we know. Galaxies, stars, planets, life, thought. Atoms are the reason this middle chapter exists. They are not eternal anchors. They are bridges, temporary structures that allow complexity to cross from simplicity into experience, and back again. They give the universe a way to linger between beginnings and endings. As you rest with this idea, imagine time itself as breathing. Inhale, energy condenses, atoms form, structure appears. Exhale, expansion stretches matter, atoms fade, structure dissolves. Nothing is forced, nothing is rushed. This rhythm does not require observers, yet it allows them. It does not aim toward meaning, yet it permits meaning to arise. The universe does not strive to be understood, but it allows understanding to happen briefly. That is enough. The fact that atoms exist at all is not a promise. It is an opportunity. An opportunity for matter to slow down, for patterns to persist, for awareness to appear. And when that opportunity ends, nothing is lost. The universe does not mourn. It does not remember. It simply continues according to its nature. Meaning is not stored in atoms forever. It exists while atoms allow it to exist. This does not diminish meaning. It defines it. Everything that matters, matters because it is temporary. Endurance gives space for experience, but impermanence gives experience weight. Atoms sit precisely at this intersection. They last long enough. They do not last forever. As you let your thoughts slow, imagine the far future. A universe vast, dark, and thin. No voices, no chemistry, no memory. Just expansion and faint traces of radiation drifting through space. This future is not empty of value. It is simply beyond value. Value belongs to the era of atoms, to the window where structure can care about itself. Outside that window, there is no lack, only difference. And here now, inside this window, atoms still hold together. They form your body. They carry your thoughts. They support this moment of awareness. You are not separate from the atomic era. You are one of its expressions. The universe is not asking you to last forever. It is allowing you to exist now. That is the quiet truth behind atoms. They do not explain why the universe exists. They explain how the universe can pause long enough to notice itself. And when the pause ends, the silence that follows will not erase what came before. It will simply surround it, just as the silence before atoms surrounded the birth of structure. Between silence and silence, atoms gave the universe a voice. And for a while, it spoke through us. There is something deeply calming in recognizing this rhythm. The universe does not cling to its creations. It allows them, supports them, and eventually releases them. Atoms are held gently within this process. They are neither accidents nor necessities. They are moments of balance. Throughout the atomic era, complexity rises and falls many times. Stars form and collapse. Worlds emerge and erode. Life appears, adapts, and disappears. Civilizations bloom briefly and fade. Through it all, atoms remain patient carriers of possibility. They do not choose what they become part of. They simply participate. An atom that is part of a mountain today may become part of a living cell tomorrow, and part of interstellar dust billions of years from now. It has no preference, yet through its endurance, preference becomes possible for systems built from it. This is one of the quiet miracles of atomic reality. Atoms themselves are indifferent, but they allow indifference to host meaning. They allow systems that can care. They allow moments that can matter. This does not grant atoms purpose. It grants purpose space. When awareness looks outward and wonders why atoms exist, it is really asking why the universe allows this pause between silences. Why complexity is given time. Why existence is not an endless blur or an eternal void. Physics offers mechanisms. Cosmology offers timelines. But the deeper answer is simpler. Because balance is allowed. The universe permits regions where forces counteract, where change slows, where structure holds. Atoms are the smallest stable expression of this permission. They are the minimal units of patience. And patience is what awareness requires. A thought needs time to form. A memory needs time to persist. A life needs time to unfold. Atoms provide that time. As the atomic era continues, It does not build toward a climax. There is no final achievement waiting at the end of complexity. There is only exploration, countless configurations tried and discarded across unimaginable spans. Some of those configurations include us, not as a destination, not as a conclusion, but as participants. This perspective softens the need for answers. The question of why atoms exist does not demand resolution. It invites acceptance. Atoms exist because the universe allows itself to rest in balance for a while. And while it rests, experience arises. As you settle into this thought, imagine yourself not as a separate observer, but as a pattern temporarily held by atomic structure. You are the universe during one of its pauses, feeling what it is like to be organized, to be aware, to be here. In the far future, when atoms no longer bind, there will be no regret. There will be no memory of this era. Yet that does not undo what happens now. Meaning does not require eternal storage. It exists fully in the moment of experience. Atoms allow that moment. They give reality texture. They give time thickness. They give silence a voice. Between the silence that came before and the silence that will come after, atoms hold the universe together just long enough to notice itself.